Good morning. My name is Arun Gupta, and today I'll talk about a day in the life of Java developer with a taste for Kubernetes. How many of you are Java developers? Good part of you, actually. So if you are a Java developer, you're wondering, Kubernetes is a new keyword that everybody is running towards. And what do I need to do in order to deploy my Java applications on Kubernetes? So this is a straight hands-on application. I'll walk through it one by one and show you exactly the steps that you need to follow. So if you look at it, this is the GitHub repo here. This is the link that you should all be aware of. All the code, all the concepts that I'm explaining are available at this GitHub repo. Okay, so bookmark this, share it with your friends, star it, any way you want to do this. That's where I'm looking for help. So first, let's look at our application right away, okay? Now, when you're talking about a Java application, you could build it as a standalone jar file, which is a fat jar. Now, in the fat jar, you have all the dependencies packaged in, or you could build it as a WAR file and then deploy it in a Tomcat or Wildfly or something like that, okay? So there are multiple varieties that you could choose from. In this case, I'm just using a simple fat jar. And that fat jar is built using Wildfly Swarm, which is Red Hat's open source application server, okay? So that's what I'm using here. Now, if I look at my application itself, the application is intentionally very simple. And what that means is, the focus is not on the application here. The focus is on how this application can be deployed to Kubernetes. Okay? So it's a simple REST endpoint. In the REST language, this is the path where the endpoint is accessible. Here is a simple method which returns a simple hello response. That's it. So as simple as that, okay? Now if I look at my pom.xml here, in pom.xml, my usual properties are defined. I can scroll down. I'm using Wildfly Swarm BOM, which is basically bringing all the dependencies that are required to build this jar file. Here is a specific dependency that is included in here, because that's how I'm able to compile my application. This is only a REST endpoint, but if I'm using other parts and pieces of the application server, then I will have to include those dependencies here as well. Using a standard Maven WAR plugin, we're all familiar with that. I'm using Maven for this, but you could use Gradle or any other build tool that comes to your taste. And then finally, I'm using a Wildfly Swarm plugin that simplifies the testing of this application on my local machine here, okay? So that's a simple pom.xml. Now, if I go back to my browser here, the first step is really for me to be able to run the application. Now, because I built the application, I want to test the application locally on my laptop. So here I am, okay? I'm going to go to the app directory. Then I will say Maven Wildfly Swarm :run. That's the plugin that was configured in my pom.xml. I give the command here. Wildfly Swarm is going to package my jar file and is going to run the application as well. Okay, as you can see, starting WAR file here. And it's firing up my server. And finally it says Wildfly Swarm is ready. Okay, so I built up my application. Now I'm going to open up a new terminal window here. And I can copy this command and make sure this application works as expected. So it returns a simple hello response string. So very clean, very simple, nothing fancy in the application. But I made sure that my application works as it's expected to. Okay. Now, my second step really here is to convert this, like if I'm taking it to a Kubernetes route, my second step here is to convert this application into a Docker image. Okay? So now when I want to make a Docker image, I'm going to use a Docker file for that. There are multiple approaches for that as well. I could use a standard Docker file to convert this into a Docker image. I could use a Maven plugin. There are a few Maven plugins that are available. There is a Docker Maven plugin by Fabric 8 team. There is a Docker Maven plugin by Spotify, and I learned of a new tool called as Jib by Google Containers team. So there are a few tools that are available that you can use within the POM XML. But using a Docker file is a very simple mechanism which allows you to run it anywhere, okay? So now I'm going to look at my Docker file here. Now Docker has this concept of a multi-stage Docker file. And what that means is, in a typical Docker file, you will have only a single from statement, which says this is your base operating system. But in this case, you can have multiple from statements. And each from statement basically means one stage of the build. So in this case, for example, here is my one stage. And the moment second from statement is specified, that becomes my second stage. Okay? So let's see what's happening in here. In this case, I'm using Maven as the base image. And I'm saying JDK 8, and I'm defining the stage name as build. I know the Maven dependencies that are required, so it's going to upload those dependencies into the image itself. Otherwise, it'll download the dependencies every time from the internet, and that makes it a little bit more expensive and time-consuming to build the image. Then I'm copying the source code into a particular directory, and then I run my Maven command. So this is going to generate my target jar file in a required directory. Okay? Now, once the first stage is complete, I can take the output from the first stage and put it into the second stage. So in this case, for example, I can say my second stage is OpenJDK, but I'm only using the JRE build, because I don't need a full-blown JDK here. I don't need to do compilation. I need to only run time, so that means it's only a JRE. And here I'm saying from the build stage, in the target directory is basically where my jar file is generated. So I'm going to take that target directory and copy it into my new image. I set that work directory to be OPT target because that's where my jar file is going to be found now. I set up certain Java options. Those Java options are required so that I'm able to debug this application later as a Docker container or as a Kubernetes pod. Finally, I set the Swarm HTTP port, which is default 8080, and then I run my application. Okay? The advantage of this multi-stage file is, first of all, I don't need to download Maven on my file, on my local machine, because I already have Maven as a base image. So I'm using Maven as a build container, essentially. Second is, with Maven, you download all the dependencies in the image, but that is only in the first stage. That first stage is discarded. You explicitly pick out the jar file from the first stage and then use that in the second stage. So your image size is not bloated that way. Okay? So that makes it easy for you to use that image. So now I can say java-jar app-swarm.jar because that's my application name. And using JRE as a base image, I can run my application very easily. So let's build this application and then try to run it as well. So if I go back to my browser here, I'm going to build this image using this command, which is saying docker image build. I tag it as Arun Gupta /greeting, and I give it a build context. Okay, so let's copy this command here, and I'm going to build the image. So it's using JDK 8, Maven JDK 8 as a base image. It's building the jar file now. Once the compilation goes through, then it's going to pick up the jar file from the first stage, use it into the second stage, and my image is ready. Okay? So now if I say docker image ls and I look for greeting, I have lots of greetings here, but this is the latest one that we just built about 10 seconds ago. Okay, so that's kind of nice. So we have the image ready here. Now I want to test this image. Okay, so what I will do is, in order to test this, I'll say Docker container run. I want to run this in a detached mode, in a background mode. Then I'll do the port forward so that I can access the application on port 8080. Then I will also expose an additional port for debugging, which is 5005. And then I will say the image name is Arun Gupta /greeting. Okay? This is the same command that is given over here. Docker run, container run. I'm giving it an optional name, so we can actually add that here. So I can call it as greeting. Port forward, run it in a background mode, and the image name. So there you go. Seems like there is a container already running here. So what we can do is Docker container rm greeting. We can remove the previously running container and now start it. Oh, still not happy. So let's take a look at it. We killed it already, so if we grep for greeting, it shows my container is still running. Oh, that is on the Kubernetes side of it though. Okay. So that's not what we are worried about. Docker container. Let's copy this command again. .8080. Well, let's try to run this on a different port. Maybe it's a port conflict for some reason. So now I can delete the previously running container, and now I can run it on port 8081. Okay, so port 8080 seems to be occupied for some reason. So what I'll do is now I can say curl http :localhost 8081 resources greeting. I get the same response. So earlier the response was coming from the Java application. Now the response is coming from a Docker image, Docker container rather. So you have gone a step closer to Kubernetes essentially. Now the next step is to take that Docker image and translate that into the Kubernetes language. Okay, so what do we do? So if I go back here, in the Kubernetes language, what we do is we create an application manifest. Okay, so what I have here is a Kubernetes deployment, and in this Kubernetes deployment, what I'm doing is I'm saying I'm giving the metadata to the deployment, saying name : greeting. I want to run a single replica of the image. I'm saying the template, again assigning some labels to it, and this is where my pod specification goes. So in a Kubernetes there is a pod. Pod can have multiple containers, but in this case I have a single container, and that is the container that I'm starting up here. So all I'm saying is the image name is Arun Gupta /greeting. Okay, and I've exposed once again the container port, which is 8080, and this is for HTTP, so that I can access my application. And then I have a container port 5005, which is for debug. Okay, so the same concept that I did for Java application, for Docker, are now can be translated into Kubernetes. Now, I want to deploy this Kubernetes application on my local machine. And again, for that, there are several options. One is if you're using Docker for Mac. So where is my Docker for Mac? So if I fire up my Docker here, I'm not seeing my Docker logo here. Okay, there you go. It was hiding behind somewhere. Okay, so if I look at now Docker, okay, if I look at the preferences, Docker for Mac just doesn't run only a Docker engine for you. It also has now the capability by which it can run a Kubernetes cluster for you. It's a single node Kubernetes cluster, but it's running on your local machine. That's the big advantage of it. There is internet connectivity required for images that you're downloading from the internet, but otherwise it works with your local Docker engine, and that is very efficient. Now remember, this is a single node Kubernetes cluster, and it is a fully conformant Kubernetes cluster. That means there is no backporting required, in case you have to go to a different version of Kubernetes, like a new version of Kubernetes from this one, okay? So you have Kubernetes is running, Docker is running. So now what I can do is I can look at, say, kubectl, which is my CLI for Kubernetes. I can say kubectl config get context. So if I have created multiple Kubernetes cluster on my desktop, by this way I can look at what sort of configurations are available for those clusters. Now if I look at it here, it's showing me 4 clusters that are created. One is, the name is AWS. Another name is cluster.k8s.local. This is the cluster that we care about, Docker for desktop. And this is lc3k8s.local. So there are 4 clusters created, different mechanisms. Now, if I were to deploy my application on Kubernetes, what I'll do is I will just change the context, say kubectl config use context, and then I will say Docker for desktop. Now, if I say kubectl get nodes, it shows me the nodes in that particular cluster. And as I said earlier, it's a single node cluster, so it shows the single nodes. Now, if I want to see the pods in that cluster, it shows me that a greeting pod is already running. I can take a look at the deployment in that cluster, and it shows the greeting deployment is running. So now I can say delete this deployment here. Okay. So deployment is one part of it. Now, deployment by default is not exposed publicly. That means if it's running in the cloud, it's accessible inside your cluster. If you were to access this deployment outside your cluster, that's where you need something like, a service. So let's take a look at greeting service here. So here, what I have is a greeting service. Now, if I look at greeting deployment for a second, in the template of the pod, I define app:greeting as the label. That means any pod that is generated by this deployment will have that metadata. Okay? So let's verify that for a second, first of all. So I will say kubectl create f, and I'm going to say greeting deployment. So all I did is I said, take this greeting deployment, the one we just saw, and create that deployment in the Kubernetes cluster. Now I can say kubectl get pods. It says the greeting pod is running, 1 out of 1. I can say kubectl describe, and I can take the pod name here, and I need to say pod/greeting this. So it gives me a lot of information about the pod itself, but the one that I care about really, if I scroll up, are the labels. It says app equals greeting. Okay? So that means any pod that is created by that deployment will have that label. So now back to my service here. I'm saying when I'm creating my service, make sure this is the label, here. Make sure when you're picking the pods from the deployment, the pods have that label. So the deployment can now, I can scale up and down my deployment, but any pods that belong to that deployment automatically become part of the service. So that's sort of the Kubernetes model that you need to understand, that service is the one that is exposed publicly. Service is the one that is looking at deployment and what are the labels attached to a pod, and deployment is the one that you behind the scenes scale up and down. Okay. Now here I'm saying type : load balancer, and so if it's running in a cloud provider like AWS, for example, then it is automatically exposed using the ELB. So that is a default behavior of Kubernetes here. So now the next step for us really is to say kubectl apply-f greeting service. So I created my service here. So now in this case, remember it says unchanged because maybe there was a previous instance of greeting running, so it just updated the configuration. Otherwise, if it would have deleted the service and created it again, it would have said created. But if I say get service now, it says my greeting service is running, okay? Now for some reason it's saying the IP address is pending, so let's do this way. kubectl delete -f. I'm going to delete the greeting service.yaml, okay? So now if I try to do get service, no service is available, and we can try to create our service again now. And now let's try to look at the service again, and you can see that it has appropriately assigned an IP address to it. So now we access the service using Java application, Docker image. Now let's access the same application using Kubernetes. So what I can do is I can say curl http localhost 8080. Well, not 8080 because the port that we exposed is 80 here. And we can say resources greeting. I get the same response. So exact same response from Java to Docker to Kubernetes, okay? So that's sort of Kubernetesize our Java application here. And if you have multiple applications, then you're looking at doing this for each and every application. It's also important that you build your workflow, essentially like a deployment pipeline, where this is done automatically for you, okay? So we saw this, we built and test using Kubernetes. Now, if your application has only, if your application consists of only one microservice, then a single deployment and a single service may work. But typically your application consists of multiple microservices that are talking to each other, in which case you will have multiple deployment files or manifest files. So that's where things like Helm kind of comes in. That's where they're very handy. And Helm is basically a representation of multiple Kubernetes manifests together, where you can actually leverage templates. So what I'm going to show you here is, if I look at my manifest here directory, say my app, this actually, let's see it in the GitHub repo. Okay, so let's go to the top. Look at manifest here. Look at my app here. This is sort of how a Helm chart looks like. At the very top level, there's a chart.yaml that gives it a more information, metadata about the service itself. Then you have certain predefined values that you can leverage in the Kubernetes manifest in the file. And this is where your actual templates live. So I have a greeting deployment, and note this is templatized. And then similarly, I have greeting service, which is again using template language. So the advantage is you can start using a fixed value that can be leveraged across different manifests. Okay? So if you go back here, what I showed you was deployment using a single manifest file, but you could have easily done this using Helm chart as well. Okay? Now, let's say my application is running, and I want to now debug it. Most of the time, well, some of the times your application works in first time, but most of the time it does not. So you need to attach a debugger to it. And when you want to attach a debugger to it, how do you do that? So now remember, we saw earlier in my greeting deployment, I have opened up a 5005 debugger port. So I'm going to go back to my IntelliJ here actually, and I will say run debug, and I will look at the edit configurations for a second. What I've done is I've created a remote configuration here. And in that, there's a default JVM setting that is specified over here. It says, have the ability to connect to a remote JVM. And again, the port here is 5005. So this is what it says, localhost 5005. Okay? Now I want to debug this application, so I attach to it. It says, IntelliJ is now connected to a JVM running on port 5005. Okay? So if I go back here now, and I try to access my application again, well, it works without jumping in here. Oh, because if we go to greeting endpoint, we have a breakpoint set up here. So let's try this again. Let's try to get more detail about get deployment. Okay, let's get the pod. If we get more detail about the pod, let's make sure the port 5005 is exposed here. Yeah, it is exposed. And the JVM is connected. And if I look at, say, Docker container ls, I think it's getting confused between the Docker container versus the Kubernetes container. So what I'll do is I will say kubectl delete -f greeting service.yaml, and then I will delete the greeting deployment.yaml, and let's see if I try to access curl now. It of course fails. So we can stop the debugger here as well. And now what we can do is docker container run. Well, we need to rm-f greeting first. And oh, I think, yeah, we are running the Docker container also on port 5005. So we need to access the application at 8081 in order for the debugger to kick in. So let's try to run this application again. And I'm going to run debug the same profile attached to localhost 5005, and I am going to access the application at 8081. The moment I try to access the application at 8081, because I have set up a breakpoint in IntelliJ, that automatically triggers in. Now, this is a very simple method, so nothing fancy here. But the point being, you can actually start debugging into your application. You can start looking at stack traces, what are the values of the application. So very simple debugging steps, but they're all available to you. Okay. So let's go back to our repo then. Okay. We talked about how do you debug Docker and Kubernetes using IntelliJ, and both the steps would work for either way. Okay. I can show the same thing with Kubernetes now, but there was a port conflict, but the same concept would work. All right, so now my next goal is, okay, I got this up and running on a local cluster. So I took my Java application, I built it using Maven, I packaged it using Docker, I deployed it in a Kubernetes cluster on my local machine. Now I want to take the same application and deploy it to a Kubernetes cluster running on AWS. So what are my choices? Well, there are a few choices. Now, I mean, at AWS, we recently launched EKS, which is our managed service. So you can easily create a Kubernetes cluster using EKS. Or, if you want to run, say, in the Seoul region, the EKS service is not available in the Seoul region yet, but you can easily run or create a Kubernetes cluster using kops, which is a community-supported tool. And that's what I have, as a matter of fact. So I have the same application running, the same cluster created using a Seoul region. So now, for that, I can look at it, say, oh, I can kill my wildfly here as well. So if I say kubectl config get context, it shows that my contexts are, because we set it to Docker for desktop, is that one. The other three contexts, one is AWS and the cluster, and LC3 are existing. So let me set up the context first of all to kubectl config, say cluster.k8s.local. Okay, config use context. Okay, so the context is set there. Now if I say kubectl get nodes, it shows me the nodes, and the fact that it shows AP Northeast 2, that means it is running in the Seoul region. So kind of gives you a feeling for that. So that's one part of it. Now I can say kubectl get pods, and it says no pods. If I say deployments, no deployments. If I say service, again, no service. So very standard. So the next question really that you're wondering is, okay, I've created a COPS-based cluster, and I want to migrate my application running on my local desktop to a cluster running in the cloud. How do I do that? Now remember, your greeting deployment, greeting service manifest, they haven't changed at all. All you're doing is you are changing your context from desktop to a cluster running in the cloud. And once you change that, then you can redeploy the same application using the same command. So now what I'm doing is I'm saying kubectl apply -f greeting deployment. Now remember, my image is already pushed into the cloud, has been already pushed into the cloud in Docker Hub for me. So if I say greeting deployment.yaml, that's created. And similarly, I can say service.yaml and likewise, okay? So now, once again, if I look at, say, get service, it says greeting service has been created for me, okay? And if I say get deployments, it says deployments exist as well. And if I say get pods, it says pod is running as well. So in the cluster running in the cloud using the same configuration file, now my application is running. Now if I get more details about the service, it says an external IP address is associated. When you were running on your local machine, it was localhost. But when you're running on a cloud provider, it is an elastic load balancer for you. Okay? So what we can do here is we can access the application. Here is my command here. Let me fire up the command here and then explain the output. Well, first of all, the elastic load balancer takes about 3 minutes, 2 to 3 minutes for it to be active. So yes, the URL has been assigned. It says could not resolve the host is because the host is not active yet. But essentially what this command is doing is saying kubectl get service greeting service, use this JSON path, status, load balancer, ingress, and the host name. So it's giving you the exact host name of where the ingress load balancer is available, and then you give it a path on where the service is accessible. So now if we try to access the same application, like maybe a couple of minutes later, by that time the ELB is already provisioned, so the app would be accessible. Okay? So let's try it again. Yeah, still in the process of provisioning. So it's about 10:07. Maybe we'll come back to it in a couple of minutes. And then we'll see the app is already being provisioned for us. Okay? So we looked at migration from dev to prod. Now, oftentimes, when you are deploying your applications, you need a lot more capabilities from the application. Canary deployment, A/B deployment, you need some sort of metrics, you need some sort of monitoring. All those capabilities are required of an application. Should you be building those capabilities in your application, in the Kubernetes stack, or how that should really work? So Istio has really gained a lot of popularity recently, which is basically a service mesh that sits in your Kubernetes cluster and gives you a lot of those functionalities. And the way this works is really it has Envoy is injected as a sidecar to each of your pod. So your pod is talking to the Envoy, and Envoy is doing everything for you, whether it's service discovery, whether it's Canary, whether it's A/B deployment, whether it's load balancing. Envoy is taking care of it with working together with Istio. Okay, so this morning I uploaded a YouTube playlist which kind of shows you different features of Istio and Kubernetes together. It's a very rough playlist at this point of time because I literally built it. I was speaking in China a couple of days ago, so I just wanted to have a playlist handy, and then I realized, oh, the playlist is there, but YouTube is not accessible in China. So at least I have the videos on my local machine, so I could play some of them. But the key that we want to show here is that all of this is a lot of fun when you start to understand the concepts together. Okay, so let's do one by one. Now, what I've done is there's a bit of a configuration required for installing Istio in your cluster. I've already done that. So I just want to verify that my cluster is up and running here, okay? So let's try to access service here. Okay, cool. So now load balancer is provisioned, and I'm getting the exact same response from my app as well. So that is pretty cool now, okay? We took the application from desktop to Docker to Kubernetes on my local machine to a Kubernetes cluster on AWS. And in between, we saw debugging as well. The next step is to take a look at the service mesh capability on my Java application here. So I'm going to, remember my cluster context is still set to cluster.k8s.local running in the CO region. So if I look at it, I just copied this command, which is basically checking for pods in the Istio system namespace. And when I look at it, it says all the pods are either running or completed. So that's the good news for me. That means my Istio has been installed here successfully, okay? Now, in this namespace, if I inject my pod, if I install my pod as is, nothing matters because it doesn't know that envoy has to be injected as a sidecar container. So if well, let's go back here for a second. And what I'm going to do is I'm going to delete my greeting service, and I'm going to delete my greeting deployment here, okay? Now, additionally, I will show you what I have is an app.yaml. I could put those greeting service and greeting deployment into a single file, and that's what I've done. So this is the app.yaml, and basically exact same thing that can be done using a single file, okay? So what I'm going to do here is I'm going to take this command, and when you download Istio, it comes with the Istio-Cuttle API, just like kubectl is Istio-Cuttle, okay? I have the Istio-Cuttle pre-configured here. So if I say which Istio-Cuttle, Istio 0.8.0 is the latest Istio release as of last May. I have the Istio-Cuttle. When I give this command here, it's saying take the manifest/app.yaml, which is my app.yaml, which has the service and the deployment and everything in there, inject Envoy as a sidecar proxy, and then generate a new app.yaml, use that to inject or to deploy the manifest, okay? So it is in here, but I need to go to java/k8s directory for this. And now I give a command, it will be able to find manifest app.yaml. So now my deployment apps greeting and greeting service are created. So if I say kubectl get deployments, it says deployments is still getting created, available is 0. If I look at it, hopefully it will be updated in a few seconds. Now when I say service, there is an IP address assigned to it already about 20 seconds ago. And if I look at pods, the important thing to notice here is 2 out of 2. So even though my application has only one container, but Envoy is injected as a sidecar container in this case. So two containers running in the pod by default here, okay? Let's see what fun things we can do with this. First of all, let's try to access this application as is. I doubt if it will be available because the host is not available. Yeah, it takes a while for the host to be provisioned, so we'll not worry about it, but we have seen this earlier, okay? Let's do fun things with it though. So now what I can do is I can delete the app and I can recreate the app where there are 2 versions of the app, okay? So let me recreate the version and then I'll explain what that app looks like. So first thing first, I am going to delete the app that we created, and I'm going to create a new app, which is app hello howdy. So let's inject that. Now let's look at the app itself. So now think about a time when you have to introduce a new version of an app, okay? So here is my greeting service, which is using name:greeting. It's saying selector is app:greeting. That's the label it's looking for. Here is my greeting hello, which says app:greeting and greeting:hello. And this is Arun Gupta /greeting, okay? Now, here I'm saying app:greeting, so this pod will be picked up. Now I also have greeting-howdy, which is app:greeting and greeting:howdy. And now the image label is howdy. The good part is that both have app :greeting. So essentially both hello and howdy images are picked up. And essentially the service is going to use them in a round robin fashion. Okay? So if I try to access the service URL, it's going to call hello once, then howdy, then hello, then howdy, in a round robin or a random fashion. Okay? So if I go back here and I try to give my curl command here, it's still provisioning the service. But if I look at, say, kubectl get service, and then I say kubectl get pods, both hello and howdy pods have been injected with envoy proxy. So let's try to access my service again. Yeah, still trying to provision it. But the point being, as we try to access the service in a minute or so, it will start round robin among the different pods that we provisioned here, okay? Now the fun thing starts is, the power of Istio comes from the fact that you can actually start assigning rules to it. That how often do you want the hello versus the howdy to be called? And let's take a look at that. Let's try it one more time. Yeah, still trying to provision the ELB. We'll come back to this anyway. So let's take a look at it, say, greeting rule here, okay? Now, because the cluster is Istio enabled, I can deploy concepts like virtual service and destination rule here. All I'm saying in this case is define a virtual service, name is greeting virtual service, host is greeting. It has two routes. One is the two destinations are greeting hello. The second one is greeting howdy. Gives 75% traffic to greeting hello and 25% to greeting howdy. And what is greeting hello and howdy? They are again defined by the labels. So everything pretty much is defined by the labels that is assigned to your pods. So let's go back here, try to access the application once again. Okay, so now the first response I'm getting is howdy. Access the application again, howdy, hello, howdy, howdy, hello, howdy, hello. So it's very random in terms of the response that we're getting back, okay? So now let's set up the destination rules that, okay, I want only 75% of traffic to come from hello and 25% to come from howdy. And how would we do that? So what we'll do is, I will apply that manifest essentially. Okay, so here I go, and I will just say apply this manifest. Okay, so my virtual service and destination rules are created. Now let's try to access my application here. Howdy, hello, howdy, hello, 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 howdy, howdy. So you can start seeing the trend that how many times is coming from hello and howdy. Now 75%, 25% split doesn't mean that for every 3 responses of hello, the 4th will be howdy. What it means is over 100 responses, 75% will be from hello and 25% will be from howdy. So that's sort of the split that they're looking at essentially. But these rules can be very dynamic. You know, at a given point of time, you can delete an existing rule, create a new rule, and then it becomes effective immediately. If I show you the greeting canary rule, the rules are very similar, but the weight distribution is now 90-10. So if I want to introduce, now let's say my service is existing, my hello app is existing. Let's say I want to introduce howdy as a greeting, as a canary. Now I can deploy greeting, but then before that I can deploy this destination rule as well, which means that only the 10% of the traffic will be diverted to howdy and everything else goes to hello. So that makes it really easy to introduce those canary deployments for your applications running in the Kubernetes cluster. Okay, so let's talk a little bit about distributed tracing here as well. So Istio comes built in with Jaeger. Jaeger is a tool which allows you to do distributed tracing. So let's say if an application that has multiple microservices where you're making calls between those microservices, Jaeger gives you the ability to show a distributed graph, essentially. So what I'm going to do is I'm going to use a port forward command here where I can access Jaeger on my local machine. Now, of course, it's running in the cluster, but because of port forwarding, I can access it locally. So let's run it here. Port forwarding is working now. So now I can access my Jaeger UI. I go here. That's sort of a funny looking icon, but I can select the service. Now it shows the operations that are available here. I can look at different details, but let's look at the dependencies here, and then the distributed application graph. Now, if I have multiple applications running here that are talking microservices among themselves, that application graph would be made available over here. So that's the cool thing about it. Another cool thing about Istio is it gives you an inbuilt Grafana dashboard. So as I'm accessing my application, it starts giving me more and more details about the memory consumption, the CPU limits, the access rate, the cadence, and all of that. Okay, so that's very helpful. So let's bring this into foreground, kill this port forward. Let's try to quickly look at the Grafana dashboard now. Okay. So I'm going to do a port forward for the Grafana dashboard. Okay. So let's look at the Grafana dashboard in this case. Here's the inbuilt Grafana dashboard for me. It says request volume. I can go down, it shows request volume, a little bit more details about HTTP services. Now, if I go back here and I try to access my application again, okay. So let's access the application a few times. Okay, and go back to my Grafana dashboard, you can see the chart is trending upwards. And you can change the refresh frequency every 5 seconds. How often do you want to refresh it? How long of a graph you want to see it? So the usual power and features of Grafana are available to you here as well. The last thing I want to show you here is how do you set up a deployment pipeline? And that is a very important aspect, particularly when you're deploying your applications using microservices. Now, there are lots of tools that are available in order to get that up and running. But the key one that I want to highlight here is Scaffold. Scaffold is an open source tool. It allows you to set up a deployment pipeline on your local machine very easily. You can set up a production deployment pipeline using Jenkins or AWS developer tools, anything that comes to your mind. But Scaffold is very easy. It really simplifies your developer experience, particularly on your local machine. That's the power of it. So what I'm going to do is I am going to go here. Okay, let's kill that port forward for a second. So if I show you a scaffold.yaml, in the scaffold.yaml, just for convenience, I'm using a different image name. I'm saying scaffold-greeting. And I'm saying pick up all the manifests which are greeting star.yaml. So which is basically greeting deployment and greeting service.yaml. It's going to pick up those two manifests. Okay. So what I'm going to do here is I'm going to say tools scaffold dev. Okay. I'm running this scaffold daemon essentially. So now scaffold daemon is now generating the image for me. Is going to push that image for me in the Docker Hub, and it's going to deploy whatever your kubectl is configured to the Kubernetes cluster. It's going to take those manifest files, and it's going to deploy those manifest files in the Kubernetes cluster so that everything just works for you automatically. And the beauty of this is every time you make a change in your GitHub repo, you save something locally, Scaffold automatically triggers and builds the entire thing for you very well. So you can see that it's preparing the image, it's pushing the images, and soon it'll basically give me a URL by which this service is accessible. So I won't dig into the detail, but the details are available in this GitHub repo, and I think we're pretty much out of time as well. So once again, in this talk, we saw how we take a Java application test it locally, build it as a Docker image, test it locally, build it as a Kubernetes image, test it locally, take that application, deploy it into a Kubernetes cluster on AWS. Then we took that application and installed Istio, traffic shifting, Canary, A/B testing, and all those concepts is what we saw as part of the application. Once again, the work is all available on this GitHub repo. Feel free to file an issue or submit a pull request, if you care about it. I'll be here the rest of the day, so if you have any questions, feel free to ask. Thank you.